Welcome to CodingCraft. In this video, we'll solve a classic FAANG interview problem called Decode Ways, and we'll do it using a clean, efficient dynamic programming approach. Here's the problem. Each letter maps to a number. A is 1, B is 2, all the way up to Z as 26. You're given a string of digits, like 111, and your task is to count how many different ways it can be decoded into letters. But there are a couple of important rules. The digit 0 can't stand on its own, and only combinations from 10 to 26 are valid pairs. For example, the input 111 has 3 valid decodings, AAA, AK, and KA. So this is really a counting problem, disguised as a decoding puzzle. Here's how we solve it. We walk through the string from left to right, keeping track of 2 counters, 2 steps, the ways to decode up to 2 positions back, and 1 step, the ways to decode up to the previous position. For each digit, if it's not 0, we add 1 step. That's a valid single-digit decode. If the last 2 digits form a number from 10 to 26, we also add 2 steps. That's a valid pair. At the end, the value in 1 step is our answer. We're simply reusing results from previous steps, just like climbing stairs. Here's our clean and efficient Python solution. We use dynamic programming with rolling variables, tracking only 2 values, 1 step and 2 steps, so it runs in O1 space. Each step performs just 2 checks, a single-digit decode and a 2-digit decode for values between 10 and 26. This keeps the time complexity at O of n, making it both interview-ready and performance-friendly. Here's the takeaway. Dynamic programming lets us break big problems into smaller, overlapping subproblems. We can use rolling variables to save memory and balance time-space trade-offs for cleaner, faster solutions. These patterns apply to many coding interview challenges. Next, we'll tackle more DP puzzles and real-world problems with clean, interview-ready code and easy-to-follow breakdowns. Don't forget to grab the full code on GitHub and check out other solutions on the channel. Join me in the next video. Let's keep solving smarter together.